add this diagram in the video, and you can see more of what I want to do. Uh, you're going to use a 230-volt metal oxide resistor because it's flame proof. You know, it'll burn up or open, but it's not going to catch a fire. Okay, so use metal oxide, and I'm going up to 1 meg. Okay, first of all, I want to say that sometimes you want to think, you know, when you take these two probes on your digital multimeter and you put a say even a 10K across these two probes, that's going to cut the impedance down on your multimeter. Okay, it'll be like you're using an analog, kind of, and that's what you want. So the question is, if I put the one resistor in there, that's what I'm reading. I think it's just cutting down the impedance on the meter. But if you're using two resistors, one across the hot, which on this one it'll be, they call it the active. Yeah, they call the hot the active. Then you got your earth and your neutral. And the same thing for the 3-prong 120 volt here in the States. You do not ever want to work on any radio without having an isolated transformer, because it's just dangerous. Any device that you're working on that's got that voltage like that, use isolation. A lot of times if I'm working on something like solid state, I can see that it's got a transformer and they're stepping it down to 12 volts. The whole circuit basically is 12 volts. It's just the transformer stepping it down for that. I won't necessarily use it, the isolation transformer, but it's good to use, because if there was a short in that circuit or something, your bulb will light up on your current limiter or your dim bulb tester. Okay, it will light up, so it's still good practice to use it on solid state, low voltage. But never work on anything without one. You gotta have that isolation first. Okay, and you're doing it at your own risk if you do this. But I think that now that we're adding two resistors, we're not fooling that digital multimeter. This is perfectly safe. It's no danger here. And I believe this is going to cut this excessive voltage, this, what I call phantom power. It'll cut it down to probably 0 or very low ghost voltage is what I'm calling it. But I'll put that in there in the video so you can pause it and see where I'm coming from. See, yeah, it says right here, Australian plug. So I guess that's the way it is down under. And then our plug. But you need the 3-prong, because you need to use that on ours. You'd have to have that 3 prongs, because you gotta go to that. And I gotta go into the plug itself. Actually, you want to go to the wire. And this one you want to go to the wire. And use that heat shrink tubing to insulate anything that you might put your hands on or whatever. But I'm pretty certain that that's going to correct the problem. I can't duplicate. I mean, I can't know for a fact, because I don't have that problem. I mean, I'm not getting that high voltage on mine. Why, I don't know. Maybe it's because I got the way I got it. Got the isolation transformer going first and then going to the current limiter. That's why I got mine set up. And then, and also mine has the Variac in there also, so it's like it's kind of easy that instead of having the isolation transformer, the Variac, or the Variac and the isolation transformer, nevertheless, it has to go into the DVT at the last point. So you might want to try switching things around like I got it, but I know a lot of you don't have that. But all of the isolation transformers should have that, just 2 prongs. I don't know about the Australian isolated transformer. They shouldn't have the earth on the input on the primary side. They shouldn't have that earth on there. If they do, that causes a problem. They got N, A, and E. Neutral, earth, okay, and active, okay. Yeah, so I'll put this in the video and you can see it. And again, you're doing it at your own risk, but I think you're going to be pleasantly surprised that it does work and it's perfectly safe. I say it's floating, and I'm not really positive about that, but I think it's what it is doing. Or the other side, if you just took the earth to the neutral, that's like I said, it's just shorting these 2 probes out with the thing, with the resistor to cut the impedance on that. And I think that's what you're reading. But if you got them both in there, you're going to get the correct voltage between the neutral and active, or neutral and hot, that the primary is getting. But naturally, it's going to be isolated, and that's what you want. So let's try this. Nobody's done this before, and I'm just doing my best to try to help other YouTubers that may have a problem with excess voltage. And I'm calling it phantom voltage when it gets that high. If you're getting a shock, it's phantom. It's gotta be. There ain't no other way I can think of it. And we're going to reduce it down to ghost voltage, or hopefully, 0 voltage ideal, but anything to keep this thing from you getting shocked if you touch the chassis and the shafts at the same time. You won't get shocked. You should not. So this is the way I'm going with it. Give it a shot, and I hope it works for you. Because like I say, I can't tell, because I don't have that problem, if this will work or not. But I do know that it does bring down that voltage from 46 volts to about 4 volts. That's not going to give you a shock. It's going to be perfectly fine. And then it's going to be safe for your testing equipment when you hook up your vacuum tube voltmeter, or your signal generator, or anything else, oscilloscope. It's all going to be safe. This is safe. It's not no fire hazard. It's not nothing going to happen. And you need to try it if you got this problem, and hopefully it will work for you. So I'll put that. Okay, I want to do a video on this Variac. Mine is a Variac with the isolated transformer inside it. I checked it. I think this is the breadboard. It's kind of blurry, but you can see the primary where your 110 volts goes in, and then your output, and just from 0 to 300. And as you can see, it's only got a 2-prong cord on it. There is no earth ground plug on this, so I'm not connected to any earth anyway. Here in the States, codes are at the circuit breaker, the earth, ground, and the neutral are tied in on the same bus bar, if you will. That's standard. I don't know what it is with the 240 volts like in Australia or other European countries, or other countries, but I'm thinking, assuming it's the same way, where you got the 240 line, single line, your neutral and your earth ground. Okay, but here in the States, and the outlets on here, you cannot hook up the neutral and the earth ground in your outlets. That's a fire hazard, and it's no go. Never. Just in the fuse panel, and that's it. But I'm trying to explain here, the best that I can, what's going on. I have it on, and we're going to check it with, I hope you can see these meters. Every one of them. Okay. So we'll start with this one if I can find the right one. Yeah. We're going to start with this one. But I'm going to show you something about them. Now, I'm not hooked up to earth, as you can see by the print there. There's only a 2-prong plug. But we're going to take this, if I got the right prongs for this fluke meter, and we're going to go to, if I don't get away of the meter, I took my thing off. Right there's the neutral, and here is the earth. I can get a good connection. I can get a good connection. There it is. 43.37, 38, 43 volts. 43.3, okay? That's going to shock the crap out of you. Anything over 30 volts, I think, will shock you. That's high. Very, very high. On a digital meter. Now here's my other digital meter. I think it's these two. And we'll try that. And you can see, if I can get it on there, can make a good fit. 40. Come on, Kenneth, get it on there. I'll make it bad contact. There it is. 47.28. Now it's raising. 47.7 volts. That's going to shock you. You're going to get a tingle. Now I'm going to show you with this analog meter, and I got this set on 10 volts purposely, and I'm going to show you the difference. Let me get it untangled a little bit. I got them all tangled up, you know. All right, now we're going to put this in there, and watch this. I got it on 10 volts on this meter. Hope it's in that picture. Let me bring that one up a little bit if I can, so you can see it. I got it on, and I'm going to the same, the neutral and the ground. Now look at that deflection there. All right, I've got about 8/10 of a volt. It'll be 9/10 if I laid it down flat. 9/10 of a volt, which is great. Okay, now you look at this. To me, that's considered, it's all what they call, let me see what my, well, it's not going to tell me on this thing, but it's all like parasitic type effect. And the reason it's only reading 9/10 of a volt here and 46, 47, whatever volts that I've got on these meters, the digital, is because these digitals are high impedance. You know, very high. This is lower. And we're loading down to variac with this one more than we are our digitals. Okay, so I prefer this one, the analog, to get an accurate measurement. So I think that we call this one, I'll try it again and you'll see if I can get it in place. Do I got the right prongs? I think I do. I don't know. There it is. 9/10 of, it's 8, but it's going to be 9 if I lay it down. That I consider as ghost voltage. You know? And the voltage that you're getting on, let's say we'll go back with the fluke. Back out again and I'll show you. Now we'll go back with the fluke, let's say. And we'll go back to the non-existing. It's not connected, but it's reading. If I get a good 42 volts on this one, 42.4. And then the other one was on the, my Owens here is going to be 46 volts. Okay, that's called phantom voltage. Phantom voltage is okay, but you don't want it that high. So, you want to use your digital meter. Now, one more thing before I go about this. I got this radio on. I'm going to take, I'll even use the digital meter, will I? Let me figure it out. If I can figure out where's my mirror. This is the one. I have this radio on. I don't have no, yeah I do. Okay, then I got the radio, one lead going to the chassis, and then we're going to go to the earth. Now watch the meter. Still showing 46 volts. Okay? I'm going to show you. 46 volts. I would not be able to handle this radio. Look at this. Both hands on the chassis. I'm going to touch the... Alright, I'm going to touch my hand right here on the chassis, and I'm going to turn the volume up. I am not getting the shock. Okay? Because there is no 46 volts on this. We'll go back with these. If I could get these on there and stay on there. Let me see what I can do with this. So, it's still reading 46 from the chassis to the earth on the digitals. It's reading high voltage, okay? Now, if I take and leave that on 10 volts, let's get this ground clip on here. And let's ground that to the chassis. Okay, then we're going to put this one back at the, hope I got that in there, but you can see it. Let me write this down. I'm going right to the imaginary earth on this here. And look at it. Same thing, 9/10 of a volt. Yeah, it's now showing 9/10. Even if it is a volt, 2 volts, or no more than 3 volts, that's considered okay. 0 is the target, but you're not going to get that. So see, that's why I'm able to do this. Able to touch the chassis. I'm going to touch the antenna, touch the chassis, and turn it, because I know there's no more than a volt, less than a volt on this thing. That's why I'm never getting shocked. I think I figured it out, the best way to cut the, I'm calling it phantom voltage because it's so high. If you're getting the shock, it's good, it's or tingle. It's a good chance that you're getting phantom voltage to the chassis through the earth ground. That's what I believe. So what I'm doing, I got, what did I put in there? 220K. I got it, two resistors at 1% now. They have to be matched. One's going to, Both of them are going to the earth ground, and one's going to the hot on that one resistor, and the other one's going to the neutral. So you can see I got 120 here, and we're going to check that with those two resistors in there. And we got 120 at our meter here. Now if I go down here and I put this one to the neutral, I'm getting two, maybe I saw 4 volts, 4.4 volts. That is, you always want to go lower. You know, target is 0, but you're never going to get that. Say 2 to 4 volts, depending how lucky I am with these. That is way better than that high voltage. Okay, you're not going to get that in the hot. You're going to get the 118, even though you got that resistor in there. But you're going to keep it there at 2 volts. So that should reduce the voltage to your chassis. But the thing of it is, I keep that in there. Yeah, well, you don't want to play ball with me. 2.2, even if it goes to 4, it will be fine. From neutral to earth ground. And we're still getting, it's just 118 out here, just dropped. And we're getting 118 at the meter. So it's not really decreasing the voltage, but it is decreasing the earth voltage, earth ground voltage. There's 3. Depends on how I touch these things. If you got it, 2.0 volts, that's really good. Okay, 2.0 volts. So the reason I'm doing that with 2 resistors is because if you just use one resistor from the earth ground to neutral, it will work. But it's not floating. You know, in order for it to be floating, you have to have one on 2 resistors. I got 220 ohms in there. One at the, both of them connected again to the earth ground, and one's going to the hot and one's going to the neutral. I'll turn it off and I'll pull the resistors out and I'll show you how I came across that. Resistors are not going to get hot, so you don't worry about it. So here are the two 220s. Hey, well, you know what though? What I did, look at this. I got one water and one 2 water in there. Are they the same values? Yeah. It should be the same wattage too. I mean, that's what it should be. But again, you take these 2 leads here and you put them in your earth ground, and that's plugged into, and then the one will go to hot and one will go to neutral on this end. You want it to float. And I was working on my radio here, and thought I would just stop, take a break, and do this short. Well, it ain't gonna be a short video because it's. But I thought I'd do that. People that's got that problem where they're getting jolted from that jazz. It's dangerous. You can hook up your testing equipment and destroy it too also. You don't want that. It's so strange that this thing is not connected to at all, but yet you're reading from it. Really, it just blows my mind. I don't know how that does that, but it reads capacitance, and maybe that has, I don't know, but I did find out that I think the fix. So again, one more time, I'm just being redundant, but put two connected together. It's like in series. And then one for the hot and one for the neutral. Put it on a plug and you just put the plug in there and just leave it, and that's it. If you don't have a dual outlet on your current limiter, DBT, which stands for dim bulb tester, if anybody don't know that, you can put one on there, put a dual outlet on there, whatever, and then go this way with it. Should be safe. I mean, it'll be floating, and that's the way you want to do it. What you do to one side, you got to do to the other. What you do to the neutral, you got to do to the hot. So put them in series, and one on hot, one on lower. These are 220Ks here that I got. Why did I pull that one? Wait a minute, did I just pull the wrong one? Yeah, I'm okay. I don't know how the heck I got that 2 water in here. If you got 2 waters, use 2 waters. If they even 1 waters, they're not going to get hot, okay? So keep that in mind. 2 resistors, hot and neutral, connected to in series to the earth ground, and I think that will correct your problem. It's worth a shot, and I hope it works for you. Give it a shot, and hopefully it works for you. If you do, if it does, let me know, because I don't have that problem here, so it's hard for me to say, yeah, it works, because I never did hot shots. I don't know why. You'll have the 3rd prong, okay? 3 conductor. You'll take the 2 together that's tied together and put them on the neutral, the earth ground. Then you'll put 1 resistor on this hot terminal and 1 end of the resistor on this neutral. 1 on the hot, 1 neutral, 1 to the volt. So now if you got this the 240 volt, the same thing, you'll have your 220. How's that going to work on you guys? Yeah, you should have the earth and the neutral and my 1 hot. That's the same thing. Try it. Put it on the and get you just a little plug. You don't need but just a little piece of plug with it, a little wire on it with the resistors on it, and use some heat shrink tubing or something to isolate anything where you won't get shocked. Plug it into your current limiter, dim bulb tester, whatever you want to call it. And I think that's going to help. I think that's going to really take that voltage off this chassis. So that's what I believe. So good luck, and let me know if it works for you. And thanks for watching.